Okay, let's talk about the third section of Chapter 1. We're going to model with some of our lines and other equations that we have. So some learning goals, we're going to write a mathematical model to solve real-world problems. We'll do some mixture problems, which aren't necessarily always chemistry. Don't think that they have to be chemistry related. And we'll use some other formulas to solve real-world problems. Okay, so let's try this problem first for an example. Why don't you guys go ahead and give us a try, and then we'll go over it together. It says you have accepted a job for which your annual salary would be $32,300. This salary includes a year-end bonus of $500. You'll be paid twice a month. What's your gross pay before taxes for each paycheck? Okay, so you want to figure out how much total money you're going to make in a year and divide that by the number of times you're going to get paid, clearly. So you're going to get paid $32,300 plus the $500, which is $32,800 for the year. And you're going to divide that by, there's 24 paychecks that you're going to receive because you get paid twice a month. There's 12 months in a year. So that's 24 pay periods. That's going to give us how much each paycheck is going to be, obviously before taxes, which gives us, so this gives you 1,366.6 repeating, it's about, so we'll say 67 cents. Okay. So the book also gives some key words here that might be helpful for you to look at when you're writing these equations. You know, equality equals is a common one. So here's an example. Sale price S is $10 less than the listed price, so that's where you use that equal sign. So you can look at some of these if you want. They can be helpful if you get stuck in a problem and you're looking for key words the problem uses to help you write these equations. That might be a good place to look. Okay, let's try another example then. Let's say you have accepted a job that pays $10 an hour, and you were told that after a 2-month probationary period, your hourly wage will be increased to $11 an hour. What % raise will you receive after the 2-month period? All right. So we want to figure out how much of a raise that is as a percentage, which is 10 divided by 11. And there's actually, the way I like to look at these problems is, I like to do, okay, well, I make $10 an hour. What would I have to multiply that by to get $11 an hour? Because that's my raise. That's my raise factor. That's my % raise. So if I divide both sides by 10, what I get is 1.1. So what that tells me is this is 110%. Okay. Basically, this is the 1 is my amount that I would make, so that's 100%. But this 0.1 is my raise amount. So I would say 10% raise. Okay, so the 1.1, I mean, this is the 10%, and this is 100%. So that's, you know, the same amount. So if this were a 10, then obviously X would be 1, which means, you know, that's not a raise. So anything more than 1 gives you the % raise. All right, let's try another example. Let's try it. This is a mixture problem. Obviously not chemistry related, using simple interest. But we need to write 2 equations. We need to read this and try to write some equations and then solve them. It says that you invested a total of $10,000. So right away, you're seeing that you have 2 different interest rates, and you're investing a total of $10,000. So let's say whatever amount of money we invest in account X plus whatever amount of money we invest in account Y has the total $10,000. So right away we can write one equation. Now it says that we have a 4.5% and a 5.5% interest rate on each of those accounts, and then during the first year, the 2 accounts earn a total of $508.75. So whatever interest rate, so let's do 0.045, which would be 4.5%, times whatever is in X, plus 0.055 times Y, which is the interest in account Y, has to total up for us the total amount of money that we would receive. which is $508.75. So the question is, how much did you invest in each count? Now we can solve for x and y. Okay, to solve these for x and y, there's different ways to do it. We could graph it. I think the easiest way for me probably would be a substitute. So I'm going to subtract x from both sides of this equation and substitute y in for y here. So you get 0.045x plus 0.055 times what y is, which is 10,000 minus x. And that equals 508.75. Then I have 0.045x plus, I'm going to distribute this to both terms. So the point, let's move the decimal place over 4, 1, 2, 3, 4, so 550 minus 0.055x equals 508.75. Let's subtract 550 from both sides. That gives us negative 41.25. Let's see, and then we want to do the 0.045, and we want to subtract 0.055. Which gives us negative 0.01 x. Divide both sides by the negative 0.01. And that gives us 4,125. So that's how much money is in account X. And then obviously just take 10,000 minus the 4,125 to find out what's in account Y. And that gives us 5,875 in account Y. So there's the amount of money that must have been put into each account. Okay, those are typical problems that you'll have to do. And I do have some of the solutions listed if you want to look through these slides. I do have this PowerPoint put on the website as well. Okay, some common formulas that you should know, or that we're going to be using, I guess. I don't mind giving you some of these formulas if you need them. Are area, square, rectangle, circle, triangle, cube, any rectangular prism, circular, cylinder, and a sphere. Those are all ones you had from geometry. Also, some other common formulas. Ferris-Celsius conversion formula, solved for both Celsius and Fahrenheit. Simple interest, compound interest, distance. All right, let's try another example then. We have a cylinder here, and we're told it has a volume of 200 cubic centimeters and a radius of 4. We want to find the height. So obviously that requires that we use the formula for a cylinder, for volume of a cylinder. Volume equals area of the base times the height for a cylinder, which the area of the base is a circle, so it's pi r squared times the height. We're told the volume is 200, so you can plug that in. We're told the radius is 4, and we just want to find the height. So go ahead and plug in 4 for r. 4 squared is 16. Divide both sides by 16 pi. And that gives us the height, which is approximately 3.98 centimeters. All right, I hope this helps.